term over here, which is d of dt of m y dot x minus x dot y. This is equal 0. Now, since delta theta is arbitrary, okay, I can set this term over here, okay, as being equal to 0. So then from here, this is 0, okay, because delta s is equal to 0. And this is 0 because at T1 and T2, delta theta is set to be 0. So I just see I copy from here, okay, since delta s is arbitrary, I just write the Lz of dt is equal to 0, which implies the angular momentum Lz is conserved. You see, to study this, you just look and pay attention, copy, okay, and understand each step, okay. The steps here mainly are based on high school course, okay. That's very easy. It's square of a sum, okay. This is square over here, see, this is square over there. That's it. That's an important relation. You see, when you have rotation, invariant rotation, you see, the angular momentum according to Noether theorem, because this is applied to the Noether theorem. You see, start from here, you see. Then you said that Lz is conserved. That's what I want for you to obtain and understand. You see, that's it.